Hi everyone. Hi everyone. And today we are getting into, or we are going to see some interesting problem. Right here we have a Lagrangian, right? So you have this Lagrangian here, this form of mx dot square of kx square minus kx x dot t. So handwriting is little bit, uh, it's not good, but you have to bear with me because there is a problem with my pen. So here we have a Lagrangian and the final result is quite interesting, right? So we have to find the dou L by dou x dot and dou L by dou x, right? So then dou L by dou x dot, we have mx dot. Once you differentiate this, we have x dot here, you will be getting mx dot, and we have x dot in this term also, and we have a minus sign, so we have kxt. And once you find dou L by dou x dot, in equation we have to find d by dt of dou L by dou x dot. So d by dt of mx dot minus kxt, m is constant, k is constant, and x and t we have to differentiate with respect to t, and x dot we have to differentiate with respect to t. So once you differentiate these two terms, for mx dot we'll be getting mx double dot. Here we have two terms, that is x and t. At first we have a minus kx dot t, and we are differentiating with respect to t, then we have kx, right? So then dou L by dou x, dou L by dou x, we have to differentiate the Lagrangian with respect to x. So we have minus kx and minus k x dot t. With respect to x, we are differentiating, right? So once you have that, then we will be writing dou L by dou x dot minus dou L by dou x. So we have a mx double dot minus kx dot t minus kx. You can see these two terms will vanish, right? So cancel each other, will cancel each other, and this with this and this with this. Finally you end up with the equation. In general it is called as a equation of a free particle. Okay, see the complexity of the Lagrangian, right? So instead of giving like this, once you have the kinetic energy of a particle, then we consider that as a, only we have a kinetic energy of a particle, then we consider as a free particle. Obviously we will end up with this equation in as two steps, but the complexity of the Lagrangian doesn't matters with the final equation, right? Once you solve the equation, the things will cancel out, and finally you will be ending up with the uh, equation of motion or equation for a free part. So in this way, sometimes Lagrangian looks more complex, but if you play with that, with the Euler Lagrange's equation, and it will end up with simple equations, right? So that's what the idea is, right? So in this video, I showed you the equation of free particle with the complex Lagrange, right? In for upcoming videos, we will be discuss some problems like this, right?